Today we're going to show you how to do the first part of our equation notes. We're just going to take a look at one-step and two-step equations and how to solve them so that eventually we can use those to solve multi-step equations. When we look at solving one-step equations, we need to know the opposite operations. And this holds true for all equations, but especially for one-step equations because we're only going to do one step, it being the opposite. So when I look at addition, I think, what is the opposite of addition? Well, the opposite of addition is subtraction. It also works the other way. If I have a subtraction and I want to get rid of it, then I need to use addition. The only other operations we're really going to work with is multiplication. And in order to undo something with multiplication, I will use division. And if I have division, then I will need to use multiplication to undo it. Here's some practice one-step problems. We're going to go through each of these at a time. I like to put lines down the middle of the equal sign to help us decide which side is the left side and which side is the right side, to help us be able to solve these a little better. So if I look at this first one, x minus 6 equals 20, I see that the x is on the left side, so I'm trying to get x by itself on the left, which means I need to move the negative 6. The opposite of subtraction is addition, so I need to add 6, and whatever I do to both sides, I'll do to the other. X equals 26. Over here on my second problem, I have x divided by negative 5 equals 8. X is on the left, and I'm right now dividing by x, so I need to do the opposite of division, which is multiplication. So I'm going to multiply both sides by negative 5. On the left side, the negative 5's cancel and just leaves me with x. And on the right, 8 times negative 5 is negative 40. Number 3, x is now on the right side. It doesn't matter which side we solve it on, but also on the right side I need to get rid of the positive 23. The opposite of addition is subtraction, so I will subtract 23 from each side, getting x to equal negative 10. Finally, I have 60 equals 5x. X is on the right side and 5 is next to it. When I see these 5 and x next to each other, that's multiplication because there's no operation in between it. So I need to divide to get x by itself. And in this case, x would equal 12. Same idea for these problems. I have x divided by 3 on the right side. I need to get rid of division by multiplying. So I will multiply both sides by 3. X equals negative 27. Negative 3x equals negative 24. When the negative 3 and the x are next to each other, that's multiplication. I need to divide to get rid of multiplication. X equals 8. Negative divided by negative is a positive. Negative 6 equals x minus 15. The x is on the right side. I need to get rid of the negative 15. The opposite of subtraction is addition, so I will add it to the other side. X equals 9. These are all one step, so it only takes one operation to solve them. Finally, on the last one, I have x on the left side. I also have this 9. There's no sign in front of it, so we assume it's a positive 9. To get rid of a positive 9, we subtract x equals 2. So those are one-step equations. All problems should be becoming two one-step equations when they're all said and done. Moving on from one-step equation, we have two-step equations. Basically what the title says. We're going to use 2 steps to solve it. To solve a two-step equation, we're going to figure out which side the variable is on, whether that's the left or the right. From the side the variable is on, we're going to move the part that doesn't have the variable on it to the other side by using adding or subtracting. Then, to get the variable by itself, we'll use multiplication or division. At the last step, it should be a one-step equation. We'll use its opposite operation to solve for it. So taking a look here at the first example, 3x minus 5 equals 34. I notice the x is on the left side, so I have to move everything from the left to the right outside of the x. The only part on the left side that doesn't have the x next to it is the negative 5, so that's what I'm going to move first. How do I move a negative 5? Well, I add it. The opposite of subtraction is addition. The 3x comes down, 34 plus 5 is 39. Now it's a one-step problem, 3 times x. How do I get rid of multiplication? I divide. Final answer, x should be 13. For my other problem, this time x is on the right side. I need to look and see what on the right side doesn't have the x attached to it. And in this case, it's going to be the positive 8. How do I get rid of the positive 8? I subtract, because the opposite of addition is subtraction. 6 equals x over 3. Now again, it's a one-step. How do I get rid of a division 3? I need to multiply both sides by 3. So I get x to equal 18. Some more two-step problems. If I put the line down the middle here, I see that x is on the left side. The negative 6 is the part that doesn't have the x near it, so I need to move the negative 6 first. How do I get rid of a negative 6? I will add 6. Whatever I do to one side, I do to the other. The x divided by 2 comes down, and I have 10. Now I need to get rid of a division 2. The opposite of dividing is to multiply. X equals 20. Finally, on the last example, this time I notice the x is on the right side, so I need to move everything from the right to the left side. The 12 is the part that doesn't have the x, so I'll move the 12 first. It's a positive 12 because there's no sign in front of it, so I will subtract it to move it first. 10 equals negative 5x. Make sure you bring down that subtraction as a negative sign with the x. I've got multiplication, negative 5 times x, so I need to divide, making sure I divide by a negative number. X equals negative 2. Positive divided by a negative is a negative. Two more examples here. I have to get the x by itself on the left side, so I'm going to move the negative 5 first by adding it. This time it not only cancels out here, but it also cancels out on the right side. Because I don't have anything on the right side, I need to put something here, so I will put a 0 because there's nothing there. Divide by 8 to get x by itself, because the opposite of multiplication is division. Anything divided by 0 is 0. So this one is 0. Same thing for this problem. X is on the right side. The 13 is the part that doesn't have the x. It's a positive 13, so I will subtract. It cancels out on the right, but on the right side I still have x over 2, so I can write that. But since it cancels out also on the left and there's nothing else on the left, a 0 will go there. I need to get rid of dividing by multiplying, but 0 times any number is still 0. The last of the two-step problems involve what happens when one of the sides starts as a fraction and total. If you notice here, the whole left side is a fraction. If this happens, what we're going to do is we're actually going to start with multiplication. We're going to multiply both sides by the denominator to cancel the denominator out. When I do that, on the left side, I just have the numerator, x minus 5. And on the right, 3 times 4 is 12. Now it's a simple one-step equation. How do I get rid of the negative 5? Opposite of subtraction is addition. X equals 17. So if our problem starts with a fraction for the whole left or right side, then I will use multiplication first. One more example of a fraction on the whole side. If you notice, the right side is an entire fraction. So when the whole side is a fraction, I'm going to multiply it by the denominator, in this case, -2, on both the left and the right side. On the left, -2 times -9 is 18. On the right, the denominator cancels, and I'm just left with x plus 4. How do I get rid of a positive 4? I subtract. Final answer, x equals 14. Don't get this confused with something that looks like this. This is not the fraction all on the left side. We would not use it for this. Only if the fraction takes over the whole left or right side do we need to use this method.